All right, so I got 16 minutes till my teacher bell. Let's go at this. This is the property of logs, and this is where a lot of times it starts getting rough. Your properties are over here to the right. So I see subtraction. I kind of glance over here. I'm looking for something with subtraction sign. Notice how this one has minus C minus D. Subtraction is broken apart through division of a singular log. You're doing what's called condensing. This becomes a natural log of 6 divided by 2, which is the natural log of 3. I know that seems funny that we're pulling these things off, and as little time as I have, let me show you their equivalent. The natural log of 6 minus the natural log of 2 is the same as the natural log of 3. If you forget a rule works, just try and manipulate it. Try and do some things in the calculator, see if you can come back up with the rule. All right, looks like I got 3 highlighted. 3 is the natural log of 6, 2 natural logs of 6. So that's this rule right here. Talks about the factor out front. We can move that 2 there and make this the natural log of 6 squared, but don't you dare stop there. You know what 6 squared is. She's the natural log of 36. All right, condensing. Condensing is where you go from multiple to a singular. All right. So first property we're going to use is this property about the exponents. Factors become exponents. And I'm going to multi-step this thing, and you should too. You're going to have the natural log of twice y all to the 1/2 power, plus the natural log of x squared, minus the natural log of a z cubed. Now, if a logarithm is positive, it goes in numerator. It becomes a argument of the numerator. So 2y to the 1/2 is positive. I'm going to talk about 2y to the 1/2, by the way. It's all to the 1/2. So you are expected to know that anything to the 1/2 power is the square root of that thing. So I'm going to write that as the root of twice y. Both the 2 and the y have that exponent. X squared is positive. Its logarithm is positive. It belongs in the numerator. I'm going to put it out here because it looks better. This guy is a negative logarithm. Her argument goes in the denominator. Easy peasy lemon squeezy if you know your rules. Big if there. All right, I got 9 and 10 highlighted. The expansion going from 1 to many. So I actually have 1, 2, 3 things in this logarithm. So I'm going to write down log 3 times. I've got a 6. If it's in the numerator, it's positive. I've got an x squared. It's in the numerator, so it's positive. This guy is in the divisor, so it's negative. There's my first line. Next line takes these exponents and moves them to the front. A log base 10 of 6 plus a log, that's not a log, that's 2 logs because we're moving that 2 out front, plus 2 base 10 logs, arguments of x, minus 4 base 10 logs, argument of y. And we got 10. And I guess I'll do multi-step. We have 1, 2 things. We actually have 3 things. We have 1, 2, 3 things in this logarithm because the square root of 9x is the square root of 9 times the square root of x. There's actually 3 things in that log. So let's do all the breaking apart first. Now, by the way, the square root of 9 is 3. So we have a log base 3 of 3 plus a log base 3 of a square root of x minus, because this guy's down low, a log base 3 of z. Now, the square root of x, again, is x to the 1/2. That's a big deal because I have to take those exponents and make them factors. Another thing is, what is log base 3 of 3? That says what power of 3 equals 3, and the answer is 1. This piece is a 1. This becomes plus a half log base 3 of x, and then minus log base 3 of z. Easy peasy if you're me. Let's see here. We got some of these using change of base formula. The full-blown change of base form is given. So I'm supposed to rewrite log whose understood base is 10, argument 12 with the desired base of e. That means I'm going to have a log base e over a log base e. And it's really simple. The number up high stays high. The number down low stays down low. 17, natural log of pi, the desired base is root 2. So now your logarithms are going to have bases of root 2. Now, ln has an understood base of e. So the top one is going to have an argument of pi because it's the big guy. And then the bottom one has the argument of the base, e. Easy peasy lemon squeezy. All right, let's save that one for class. I'm sure it'll go to ask. We got some arithmetic sequences we have to do. An arithmetic sequence is given as 4 blank 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 12. If only I could add 6, 8, 10, 12. The difference here was 2. So find the missing terms. I did that, write both the explicit and recursive rules. So the explicit form is given up top. You probably have nightmares of this thing. But for the explicit rule, the nth term is the first term of 4 plus the difference, which we discovered was 2, times n minus 1. And you may or may not remember this, but your goal was to make this look like mx plus b. That was your goal, because all lines are arithmetic. So let's go ahead and distribute that 2. That'll give us 2n minus 2. And then we'll combine like terms, and we'll get 2n plus 2. That's the explicit rule. The recursive rule is also given to you. You got your set of curly braces. Ace of 1, which is 4, if you're at the first position. And then ace of n minus 1 plus d if n is greater than 1. So ace of n minus 1 just stays ace of n minus 1. And then we have plus the difference, and the difference was 2. And that, again, we have to finish it if n greater than 1. Easy peasy lemon squeezy. Let's do a sigma notation. This is sigma. It means sum of. That's what she means. Now you're going to need a formula that I had not given you on the piece of paper. It's that the sum of n things, maybe you remember us doing this, maybe you don't. It was given to us by a very young kid. He was only 8 or 9 when he came up with it. Sum of n things is n over 2 times the first term plus the last term. So I'm going to find the first term by actually plugging in a 4. The first term on this thing is actually the 4th term, and the last term is the 11th term. So I got to find ace of 4. And I do that by literally putting a 4 in. 3 times a 4 and a 4. That's going to be 12 plus 4, which is 16. The last thing is called ace of 11, and she's done by plugging an 11 in. She's 3 times 11 plus a 4, which is 37. Now, n is always high minus low, and here's the big part, plus 1 back. Because you're counting 4 through 11, including 4. 4, 5, 6, 7, 8, 9, 10, 11 should be 8 things. But if you just do subtraction, you get 7. But it's 8. And then I'm going to feed my little formula. The sum of 8 things is the number of things, 8 sitting pretty over 2, times the first term, which was 16, plus the last term, which was 37. Let's see, the sum of 8 things, I'm just going to do it by hand. We got 4, 16, and 37, I believe, is 53. 54, 53. I was right the first time. And 4 times 53 is going to be 212. All right, 25, just so I don't get asked about her in class. The sum of the first 15 terms of an arithmetic sequence is 645. So I'm going to go ahead and write down my little formula. The sum of n things is n over 2 times the first term plus the last thing, because I saw them mention sum. Now I know there's 15, so everywhere I see a 15, I'm going to put in a 15. The first term is 1, I'm going to put a 1 in there. I do not know the last thing. And by the way, should not have said sum of 15 there. The sum was known to be 645. Plus ace of n. Now what the deuce is ace of n? Well, ace of n is, watch, it's the first term plus n minus 1 times the difference. First term is 1. If I'm talking about being 15, because it's the 15th term, it's 15 minus 1 times d. Because I'm actually finding ace of 15, because it's the last term. All right, anyway, I get 1 plus 14 d's, and I can put that there. Now, what I've done is I've rewritten the information I have, and I've given myself an opportunity to figure out the common difference, because if I have the common difference, I can figure out the explicit rule. Anywho, 2 plus 2 is 2, or sorry, 1 plus 1 is 2. I've got 15 over 2 equals 645. And there's a couple different ways of approaching this thing. You might just clear the fraction by multiplying both sides by 2, because the opposite of division is multiplication. So twice 645 is 1290, right? I think that's right. 1290 equals 15 times 2 plus 14d. And let's see if 15 enters 1290. It does, and I thought it would. It enters it 86 times. So I'm going to divide out my 15, and I get 86 equals 2 plus 14 d's. Subtract my 2, I get 84 equals 14 times d. And what's that take? 6 times? The difference is 6. Now, I don't know why I wrote A. Probably because I was thinking about this guy. The explicit rule is that the nth term is the first term plus parentheses n minus 1 times d, and the d can be in the front or the back. It don't care. There's a joke in there somewhere. Can't talk like that anymore. But the nth term is the first term of 1 plus the difference, which is 6 times n minus 1. Distributing, I get 6n minus 6. Don't forget about the 1 plus. 1 minus 6 is negative 5, so the nth term is 6n minus 5. There you go, kids. Nice and quick, too. What did I do here? I did 1, which is a big one, 2 problems, 3 problems, 4, 5, 6, 7, 8, 9, 10. So I did over a third of your homework. You could say thank you. You could. You probably won't. You're probably mad at me for giving you homework. But you're in a math class. Get used to it.